G'day and welcome to the third part of the cubics and quartics revision. This first question we have here is find the equation of the image of the graph of y is equal to x to the power of 4 if it's transformed under a dilation of factor 5 from the y-axis and then by a translation of 3 in the positive direction of the y-axis again. Now, I explained a little bit in a previous video about these dilations, so I'll plough straight into this one. What we need to do is to firstly apply the dilation. So if we look at the dilation, we would treat it, if it was a dilation of a factor of a from the y-axis, then we basically evaluate it if it was x over a as a function. So in this case it's dilated a factor of 5 from the y-axis. So we're going to evaluate x over 5. And in our equation we've got y is equal to x to the 4, the function of x equals x to the 4. So we're going to substitute x for x over 5. So this would become x over 5 to the power of 4, which is x to the 4 over 5 to the power of 4, which is x to the 4 over 625. So that's applied the dilation component of it. And then for the translation, this is a translation of 3 in the positive direction of the y-axis. So it's shifting the graph upwards by 3. So that one makes it actually quite easy for this one. So that will tell us that the equation of the image is going to be x to the power of 4 over 625. And then for the translation upwards we go plus 3. And that's the answer to that. Let's move on to the next question. This question here we have multiple choice, which I've just taken this straight off the revision sheet that I've handed out. Thanks to Evans, Lipson and Wallace for producing this question back in 2006. A possible sequence of transformations which transforms the graph of y equals x cubed to the graph of y equals x cubed plus 3x squared plus 3x plus 7 is, and all of these are talking about translations which are going to be shifting it in the x direction and or the y direction. So we're going to be looking for an equation, something in the form of, could be an a at the front, we don't know. I'm not really interested with that. So something in that format. So it's going to be shifted left or right according to what's in a bracket, and it's going to be shifted up or down according to what's not inside our cube bracket. In this case here we've got a 1x cubed, so we can fairly safely say that our a value is going to be 1. And to give us an idea about what's going to be inside our bracket, if we look through all of the different options that are there, they're all talking about 1 unit in the positive or negative direction of the x-axis. So it's going to be something related to either x minus 1 cubed or x plus 1 cubed. Then it's going to be plus or minus something. So obviously the easiest way of doing this is to actually get your graphing calculator out, your CAS calculator out, and plot a graph of it, which I've done here. And let's just get this photo up, which you can see here. I've actually gone through and calculated the point of inflection for this particular graph. The way you do that is plot the graph, obviously, press the menu button, then go down to number 6, Analyze Graph, and you'll see various options in there for 0, minimum, maximum, intersection, inflection. which is the one I used there. And you can quite clearly see that the point of inflection on this one is at -1 and 6, and -1 and 6 would refer to this second option here. I'll get rid of that one, and so that would tell us it's been translated by 1 to the left, and then for the y coordinate would be a +6, indicating it's gone up by 6. And looking through all of the options that we have, 1 unit in the negative direction of the x-axis and 6 units in the positive direction of the y-axis would be option D. Okay. Now, the other little thing that I recognised when I looked at this question, this was just something from a bit of experience, is that if I was to take x plus 1 cubed, excuse me, and expand it, then that would be equal to x cubed plus 3x squared plus 3x plus 1, which most of that actually looks the same as the original question. The question's got a +7 in it instead of a +1, so that there is also a little trick to let me know that that's going to be a graph of x plus 1 cubed plus 6, which if I take the expanded form here and then I add another 6 to it, that gives us the +7 that we have as part of the original question. If you're not familiar with the expansions of these, then good idea to do so. I'm just going to see if I can reduce a few of these things to show you a little bit of, oh, look at that, parts of it reduce and parts don't. That's interesting. Anyway, it gives me a bit more room anyway. I can shift that all up over there somewhere. Yeah. So what I was going to show you is Pascal's Triangle, which we start with the 1 at the top, go down with 1s either side, and then we go 1. The 2 1s in the middle add up to a 2, 1 down the outside, then we go 1, and these 2 here will add up to 3, and then these 2 add up to 3, then we get a 1 out the outside, then we got 1, 1 and 3 adds up to 4, 3 and 3 adds up to 6, 3 and 1 adds up to 4, and 1 on the outside, etc., etc. And the way that that works is, for the first line here, that's sort of like x plus y, y to the power of 0. Then the next line here we could sort of represent x plus y to the power of 1. You're thinking, what, this guy's an idiot, what's he talking about? Anything to the power of 0 is equal to 1, so we've got the top line equaling 1. The second line, x plus y in a bracket all to the power of 1, and let me just shift some of this other stuff out of the way again. Don't need that for now. This is just equal to xy, x plus y. So coefficient of x is 1, coefficient of y is 1. If we go into the next line down, we can say that that's x plus y squared, which is equal to x squared plus 2xy plus y squared, where the coefficient of x squared is 1, coefficient of y squared is 1, and the coefficient of the xy term in the middle is 2. If you notice from Pascal's Triangle, the same order, it's 1, 2 and 1. So they tell us the coefficients, and this is where we now go into the third one here. So 1, 3, 3 and 1, where the significance of that is we could do x plus y cubed is going to equal 1, and then we take the first term, which is x, to the power of 3. Then we go on to the next term, so we look at the coefficient, it's 3 over there. And then what we do is we reduce the power of x by 1, so we go x squared. and then we'll increase the power of y by 1, so we go for y. The first term here, it's like we have y to the 0. The second one is y to the power of 1. Now looking at the third term, we go to the next coefficient, which is a 3. Write that down. We reduce the power of x, so x goes from 2 down to 1, then we increase the power of y, so y, that goes from 1 to 2. And then we look at the last coefficient, which is a 1, plus 1. We reduce the power of x again, so x goes from the power of 1 to the power of 0, which is just 1, I'm not going to write that down. And we increase the power of y, so that becomes y cubed. And that would, I'll just get rid of those 1 coefficients, so that would mean that x plus y cubed is x cubed plus 3x squared y plus 3x y squared plus y cubed. Okay, and I'll also go through showing you how this 14641 works. That might be represented by x plus y to the power of 4. So to expand that out, we take the 1 coefficient at the start, so that's 1, and then we start with the first term, which is x to the power of 4. Next term, coefficient of 4. We reduce the power of x by 1, so that becomes x to the power of 3, and we increase the power of the second term, which is y, so y to the power of 1. Plus the next term, we have 6 as the coefficient. Reduce the power of x, so x squared, increase the power of y, y squared, plus next term is 4, and then we reduce the power of x, so that just becomes x, increase the power of y, y cubed. And then the next term we have a coefficient of 1, x to the power of 0, we've decreased that by 1, I'm not going to write that because x to the power of 0 is just 1. And then we increase the power of y, which takes it to a power of 4. So x plus y all to the power of 4 is equal to x4 plus 4 x cubed y plus 6 x squared y squared plus 4 x y cubed plus y over 4. So knowing a little bit of these expansions and becoming familiar with what they look like may save you a bit of time. And as I said, when I looked at the original question, I started to recognise the pattern in here for the expansion of x plus 1 cubed, because I noticed the coefficient of 1, the coefficient of 3, the coefficient of 3, which was the same as in the original question, the coefficient of 1, coefficient of 3, coefficient of 3. So actually putting a few of those things in your memory bank can save you a little bit of time possibly in the future. Alright, so let's move on to the next question. If you wanted to go back and have a look at the original parts of the solving of that in the calculator and whatever, you might need to just replay this little bit because I've shifted everything everywhere. Okay, next question. Okay, next question here. Again, it's a multiple choice. Now, of all of these options that we have here, because we have a turning point which is happening at -1, that's going to represent a bracket of x plus 1 squared. Okay, and then over here we have an intercept at positive 3, that will represent a bracket of x minus 3. So to look through all of these options, which one of these has an x plus 1 all squared and an x plus 3 is option C. So that would be the correct answer for that one. So when you're identifying this, if you see something which is an intercept, then you just take one bracket from that. If there's a turning point which is happening, then you need to square it. If it was a point of inflection, then it would be a cubic type graph. Okay, we'll move on to the next question. Okay, this is another one where we're looking at a possible equation of a graph. So this one is going to be in the shape of a cubic, And we have a point of inflection in here. And this would be represented by positive 1, and looks like it's been shifted down by roughly negative 1. So going across by 1 and down by 1, this would take our normal x cubed graph. To shift it to the right, we turn this into an x minus 1 cubed graph. And then to shift it down by 1, we then create this x minus 1 cubed, take away 1. Okay, so this bit here shifts it to the right by 1, and the bit on the outside will shift it down by 1. So looking at which of those options we have is option D. So that's the answer for that one. Let's move on to the next question. The polynomial p of x equals x cubed plus 2x squared take away 10x plus d is divided by x minus 1. Find d if the remainder is 6. So if we use our remainder theorem, that would be, we look at this x minus 1, set that equal to 0, rearrange that, x will be equal to 1. We want to substitute x equals 1 into this equation. So p of 1 will be equal to 1 cubed plus 2 by 1 squared, take away 10 by 1 plus d, and we're told that the remainder is 6, so we set that equal to 6. So that tells us we have 1 plus 2 times 1 squared is 2, take away 10 plus d equals 6. Simplify that, 1 plus 2 is 3, 3 take away 10 is negative 7, plus d equals 6. I'm going to add 7 to both sides, which will give us d is equal to 7 plus 6 is 13. And that's the end of this particular broadcast, so hopefully you found this to be a bit useful.